Engineer contractor at DAZN. Just to say a few words about me. So I'm for years and years in front-end development. Basically, I'm an accessibility enthusiast, and recently I activated myself to motivate more women to code, and that is my next goal. Today, what I'm going to talk about is about what we are doing at DAZN and how we are actually developing applications in JavaScript. Anyone heard about DAZN before? No. Streaming. Okay. Yes. So it's basically a subscription-based sports streaming service, very similar to Netflix. It's already in a number of countries. I think on 3 continents. We are just getting into new markets. Unfortunately, it's still not in UK. So DAZN is offering live and on-demand streaming of events, and it's present almost on any connected devices, like, of course, web, but also TVs, phones, tablets, game consoles, and so on. So this last sentence actually creating a challenge for DAZN. How to build this application? How we to have actually be more performant during the build and have as much as we can a common code. So there is a challenge, right? This service should run on different operating systems. Performance-wise, because of different systems, we have the latest game consoles, up to budget devices like Fire Stick, especially Generation 1, that is having a limited memory and processing power. Then again, we have multiple regions, so content and localization is another challenge for us. Input controls, you have to think about input controls. So beside mouse pointers, we have the remotes, game controllers. Someone brought in a guitar a few days ago. So, and the last is that the user experience has to be similar. So UX would like to provide a similar user experience across different devices, but feature-wise, it's going to be again different. For example, from TV devices might be a little bit more complex to sign in or create an account or do the payment. So we might do it through the web and then access it later from the device. So the DAZN approach, and basically we have 3 different streams and 3 different basic themes. One is the web platform. Then we have native apps for mobile and tablets. And the third stream, where I'm working for, is something that we like to call living room devices. And based on the stats, it is taking more than 53% of market, I think. Again, we have 2 big groups here, where we have device-specific products like Apple TV, Roku TV. That is especially popular in Canada and US. However, in Europe, the market share, and Japan also, is mostly on Android TVs and Fire Stick. We have DAZN TV, that is a Samsung operating system, and then PlayStation, Xbox. So the team where I'm working is called like device porting. And the challenge in front of us was that we have to provide similar experience across all the devices. The UI that accept inputs from different controllers, as I had mentioned before. And again, adaptability of the user experience based on the device performance. So if I have a budget device that might not be able to take heavy animations and so on, so we have to adapt to that device. So application should recognize it. And what we did, how we started, we decided to create a hybrid app where we are leveraging the Android web view with Cordova. And again, we are using a common code base using standard web technologies, HTML5, CSS3, and JS. So we have one common code base, and for each device, through different automation scripts and so on, we are creating customizations with module swapping. And I'm going to talk now about this. I think it's quite interesting. We are using micro-frontends architecture. And this is our architecture. So you have, I guess it's quite standard. I guess some of you already developed hybrid apps. Anyone? So we have a Cordova wrapper. What it is providing to us, it is providing to us a communication between the device OS and our web app through the web view and Cordova plugins. Cordova plugins are used basically for things that the web view wouldn't recognize. So it is not standard HTML5 API, but it's coming from the native OS. So with the help of Cordova plugin, it would get translated, kind of bridge between our web view. And I will talk more about our web app. What we are doing is something that we call something that is called actual micro front, and I think it's a very, very interesting approach. I facing this first time since I'm working on this project for about a year, and I really like it. So we have something that is called Bootstrap, or it's a booting JavaScript, and then we have multiple chapters. Each of the chapters are actually a single page application. And if you're looking into the Bootstrap, what it is doing, so it is a really small JavaScript layer that is coordinating our micro frontend. So it's coordinating between our chapters. It is responsible for the application startup, so it would download, it would connect to the services, to the API, and download the translations, or would check for if the token, authentication token exists, and so on. Also, it would be responsible for the routing of our application, download the chapters, and we have something that we call a global API or global DAZN variable, and Bootstrap would expose it toward our chapters. So the communication goes this way. So each of the chapter would communicate with the Bootstrap, and the Bootstrap would know which chapter to load in certain moment, or to provide, or there are a set of listeners on the Bootstrap side, and it would react on a way how the chapter would actually changes global variables. Each chapter would communicate with the API, but never with each other. What we get with this, that each chapter is tech stack agnostic. What does it mean? So each team is responsible for their own tech stack, so they are really free to choose their own tech stack and how they are going to do things. Very important to say that nothing is shared between the chapters. So even if we have reusable components like whatever, header, footer, we are not buttons, right? So we are not going to share between the chapters. Each team will going to develop their own. So communicate they communicate with Bootstrap by altering the global variables, and as I mentioned, they send and receive requests via API gateway. How it looks like. So when the application loads, Bootstrap is already there, and it would parse the HTML and inject a specific chapter into our HTML page. This part here, for example, server-side load. I put the slide in here just to be a little bit more clear how we are doing things and how we are actually releasing and deploying our app with the chapters and Bootstrap. We can come back to this later. So when we creating our APK, our package that is going to be installed into the device, and all these chapters are actually living somewhere in the cloud, in our case on S3. And what is important during our build, our deployment, we are actually not compiling runtime. So we have a number of bundles that are placed in different folders by region and by chapter. So Bootstrap would reach for them toward the static files and download them. I'm going to talk to you about catalog chapter. Catalog chapter at DAZN is basically, if you can visualize, I didn't create any screenshots, so I'm sorry. If you can visualize Netflix, for example, and you have those rails and you have those tiles that are moving left, right, up, down, and so on. I think I'm missing one slide. Okay. I want to talk about our challenges that we have to overcome. So one of the most important are the key navigation. The second is the focus management, and third is performance. Why the key navigation is challenging? If you're using remote controllers, you don't have key events. Although, again, some TVs are having pointers, like LG TV, I think. So they are having that ball-like pointer, so you could point and you would have a mouse over effect event, and then when you click, it would be a click event. Those focused elements can have multiple interactions. So when we're focusing on a certain element, then they can go left, right, up, down, right? We can select or enter and have a back button. What is challenging here that we can map the left, right, up, down to our keyboard events, and usually it is the same mapping on the device controller itself. Select is usually the enter, but the back button is something different. So it's coming from the device OS, and it is actually an event that we are getting from Cordova.js, and then I think it's called back button. So as you have click event or key pressed, it's called back button. So we have to intercept that back button, because if you press the back button, it would exit the application. With back buttons, sometimes you want to just go back in history. Sometimes we can have another event, just close a model or whatever. So I mentioned the pointer remote, right? And then also what is very challenging that we have these key mappings can be different per controller. So first time what we faced is there is an NVIDIA controller that is kind of joystick-like game controller. People are using it very often. And key mapping is different. So what would be the solution for us here? That in our case, Bootstrap would recognize our device and would provide toward the chapter the proper key mapping. So that would be, for example, a shared thing between the chapters. The second challenge for us is focus management. So as I have mentioned, so in every moment our application state has to know which component is focused. Can you imagine if we lose the focus, how we can get back so we don't have a click? So our application is failed. I guess we have to reset the device. So we've been considering two types of focus management. One is the special navigation. Anyone heard about special navigation? So it's very browsers using it for tabbing through the components, right? Through the links. And then declarative focus. So special navigation, special algorithm that would recognize the nearest component. It can be really smart. However, we think that we cannot apply into our application a special navigation, especially because UX sometimes don't want the next focus to be on the closest component. So we decided to go with something that we call declarative focus, where each focusable component, so we define the focusable, declare the focusable component, and it can have its own focusable state. The next challenge would be, okay, this is our focusable rail, right? So the first item is focused, and it is easy if I want to go left, right. However, if I want to unfocus the component and focus on the next one, it's going to be challenging. So I want to reuse this component, right? So how we are going to deal with this kind of situation, because I might reuse my rail on different page, and then the down focus would be button, for example. In other case would be a rail. So what we figured out is to actually create a focus store. I'm going to talk a little bit later about these stores, where we are using two properties only. It's really, really simple, the whole focus management. So when we load the application, it is always having a default focused element. So this is how we started. And then we always know, in every moment, we always know which component is in focus, and in that component, in which context is it. So we are calling those pages of ours context. And we can have two actions. So whenever we press some button, left, right, up, down, enter, and so on, either set the focus and also release the focus. Beside that, we have something that is a map of our focusable components. We are calling it app focus tree. I can show you later if anyone interested in that. And the third challenge is the performance, and I think it is really an ongoing thing and work in progress. Every day we're finding out new issues and resolving old ones and so on. What are the challenges? So we have, as I mentioned earlier, devices with low memory and limited graphic acceleration. Then what we are measuring is three things. The key input responsiveness, then time to interactivity. So time to interactivity is basically when we load the application is ready, all the dependencies are loaded, right, into our page, and all the events are ready. So all the event listeners are set up. What the next thing? Frames per second for animation. So we are doing some animation via scrolling left, right, or those rails up, down. So it's some things are happening on the screen. So what we are trying to achieve is, of course, 60 frames per second. Sometimes we can, sometimes not. What we are doing is using CSS for animation, trying not to use JavaScript because our animations are really simple, and also trying to do this animation on the composite part of the rendering of the page of HTML. So using opacity and transform property and translate. We did some profiling, we did some React profiling and so on. We've been improving our practices, how we are writing code and so on and so on. The development stack we are using is React, but only for views and components. So we are not putting any business logic into React. We are not having any life cycles in our React components. For app state management, we are using Mobx state tree. And here is where our business logic actually lays. For key mapping, RxJS. For styling, CSS Next. And testing with Ava and Enzyme. So we didn't do any integration tests so far. Automation, unit tests are there. End-to-end testing is work in progress. And yes, I think this is important. So this was really a paradigm change for myself a year ago. Functional programming and reactive programming, and I really like it. Anyone familiar with Mobx state tree? Okay, I'm going to explain it really fast. This is an example from their website. So let me say first this. So basically, what we are we have Mobx, and top of the Mobx you have the Mobx state tree. Mobx state tree is actually a very opinionated framework, and it's pushing you to write the code on a certain way, and I think it's good for us as a team. So one important thing, we have the observer here. And it's coming from Mobx. All our React components are observers. Our stores are observable, so the component itself will react to any change that's happening inside my store. So that is kind of reactive way of writing code. And yes, we are writing in ES6. Actually, this is ES7 already, right? Actually, this is the most important part of the Mobx. So what it is doing, so it is defining the state of our application through the model, so through its properties, but it's also defining how they call it, the shape of our state by defining the types. So it's very interesting. We have so it is really strongly typed. You have to define all the types that your model would use. It would throw an exception if you would if during the runtime you would try to change the types of the properties. The views function here is actually just a computation, and it's getting new types and adding to our model tree. So they are not saved, I have to say. So they are changeable based on the current state. But through views, we cannot change the model. We can change the model through our actions. So if we would like to change any value of our model, we will do it through the action. If I go back to the React component, you would see that we are actually injecting our to-do store, and we are getting it as an object in the props. So we can actually print out the things from the store, from the views, from the model, and also create some action from here. So for example, if button pressed, we can add a new to-do item into our store. So one more thing that I was not talking about, it is really not something what my team is doing, but I think it's worth to mention because DAZN is a streaming company, right? So it's streaming sport. And I haven't talked about playback at all. So how we are going to implement the playback into our catalog is work in progress again through Cordova plugins. And the playback team is facing again challenges like low power devices, and they are evaluating the best protocol per device, and they're trying not to interfere with performances of our chapter of the catalog, because basically playback and catalog has to work together. So again, the same challenges as we have in catalog. And what they have decided. So this team has decided that they will go with the Java exit player embedded as a Cordova plugin. And it means that it's going to run a separate thread than our web app, actually the web view. And we're expecting it to performing much better than to run in the same thread. So Android player view behind the transparent Cordova web view. So that is something like, okay, our catalog is going to be transparent and behind is going to be the player. But still we have to create this interface and to communicate between our catalog. So, and on the other way from playback towards the catalog. So here is where the Cordova plugin comes in place. And here, that is how we are going to create this interface. I think that's all. I added a couple of links. So first of the link is DAZN engineering. So you can find here current openings in DAZN and a couple of things that's what we are doing. I think some blog articles. Mobx State 3 docs, and then the GitHub link, then CSS Next, Ava, Cordova. Thank you.